All right, we're going to go over a schematic design for a really cool and simple circuit that you can use with your Arduino sort of as a gamepad. So it's called the joystick follower. The basic idea is we'll have a joystick and maybe some buttons where the joystick, when you push it and move it, it will turn on LEDs corresponding to the direction to which it's pointing. And then maybe on the circuit we'll also add some buttons. So it's kind of like a gamepad. Um, and cool feature we'll do with it is we'll make it a shield or hat for an Arduino Uno. That means we can, build the circuit, we can place it right on top of the pins of the Arduino and connect it with all the functionalities of the Arduino, um, just to make a really useful and fun circuit. So what we want to do is do the schematic design, and we're going to do that in a schematic design software called KiCad. So we'll go through setting up a project and building the schematic, and in a later part of the video, we will go through the printed circuit board design. So making that professional looking board that you get printed by a manufacturer and then you solder together. So first off, let's kind of go through just the paper brainstorm design to know what we're going to design. So this is a really good first stage to do. So the joystick follower will use a single joystick. Um, And these joysticks are two-axis potentiometer based. So that means we use one potentiometer to control the vertical axis and one potentiometer to read the horizontal axis. And these will be connected to the analog pins of the Arduino. Um, the joystick also has a push button, so if you're familiar with like a PlayStation 2 controller, you can also push down on the joysticks and it'll do a click as a button. So we'll also be able to use that button on the joystick. There'll be 4 LEDs kind of surrounding the joystick in a cross manner. So when we push up, the top LED will go on. Maybe if we push to the bottom right, the bottom and right LED will go on. So we have some LEDs as fun indicators with where the joystick's pointing. And then a green LED to also indicate when that joystick button is pushed down. Furthermore, I added 4 additional buttons since we have extra pins on the Arduino to use. That way, we have a joystick and buttons, so this could work as a little mini gamepad. Maybe you want to connect this up via USB to a Python script and play a Pi game and use this as sort of your controller. All right, and as we said, the PCB should be an Arduino Hat for the Uno R3. So that's the most up-to-date version of the Arduino Uno. And when we solder this together, you'll essentially just be able to stick it on top of the Arduino, code it up, and on your way. All right, so let's look at the basic sort of block diagram drawing of what I was thinking this would be. So sort of this outline, which is about, what the size of the hat will look like. On the left side, we have our joystick with our 4 red LEDs around it and that cross-like pattern. Then we have a green LED. That'll be from when the buttons press down, and then our 4 buttons to the right. So these are sort of, gives us the basic idea of what we need to look into. Now from that, we can start looking into parts and designing the schematics. So let's first go to the schematic. So there's kind of a lot here. And it takes time to build these schematics, but I have one right here for you guys. So let's go through each of the components, starting from the top left. So the top left is the 4 buttons, which will plug into digital input pins of the Arduino. And we don't necessarily have to know which exact pins yet, we just need to know that we have enough. And in this case, there's plenty pins on the Arduino for this project. So we have 4 push buttons, and they're connected to what's called a pull-up resistor. So that means when the button is not pressed down, the digital inputs of the Arduino will read high, or read 5 volts. And then when we push that button down, the Arduino will read low. And these pull-ups or pull-downs are essential. That way you're not in a tri-state mode where the Arduino doesn't know if the pin is high or low. And we did them externally. You can do this internally, but I thought it'd be a good little learning time about what pull-up and pull-down resistors are. So we just included it externally. Now, at the bottom, we have our LEDs, which are driven from digital outputs of the Arduino. So we got, I only show 4 here. We technically have 5. I left out the green LED, so we'll make sure to put that in when we actually go and design the schematic in the software. And these are connected to current limiting resistors. That way, we don't pump too much current through the LEDs. And um, yeah, so we just, we need those current limiting resistors, and we'll go through with what values those should be. Now on the right side, we'll notice, you may notice, why is the joystick not here? Well, I represented the joystick sort of based on its circuit model. So the joystick has 2 potentiometers, like I said. So these are the symbol from the potentiometers, and we'll take that middle pin and we connect it to the analog inputs. So since 2 potentiometers, we'll go into 2 analog inputs, which will be converted to some digital zeros and ones by the analog to digital converter on the Arduino. Furthermore, we also have the button on the joystick itself, and so similarly to the pull-up resistors given in these 4 buttons at the top, we'll have the same configuration for it at the bottom. So this is the basic idea, and this is a good starting point where we know the components that we need in order to start. All right, so now we're ready to start our KiCad schematic design. So we'll open up KiCad and you'll be presented in this window. You probably won't have this stuff on the right, on the left, but you will have, all these different options of things you could choose. So this includes a schematic layout editor, symbol editor, printed circuit board layout editor, and multiple other features that are really useful and convenient thanks to KiCad. So first thing we'll want to do is create a new project. So go to the top left, click New, Project, and then let's save it to somewhere. So maybe we'll go here. So I believe I have a folder for KiCad projects, and we go joystick follower. So we'll save that, and here comes our project. So you'll see 2 files pop up in the left. You'll see the KiCad PCB, that's your printed circuit board, and then this .sch, which is your schematic. So we'll get to the PCB later on. That's the cool physical board that you actually see, but first we need to design the schematic, which will then be linked to the PCB and help us build that. So let's just click and open the schematic. So here's your schematic editor. Kind of looks like a formal piece of paper you'd print out with a blueprint. So the first thing we'll want to do before placing down any components is let's change the page size, because you may want to actually print out your schematic, especially if you're going to build the board, because it's often useful to print it out and highlight the parts as you're putting the parts on your board so you know which parts you put down. So we can give it an issue date, we could give it a revision, so we might go revision A, title, so we'll go, joystick follower, company, you can put whatever you want, and then a comment, so I might put like author, Pierce, put your author, and you could fill these out as you wish. So we'll create that, and that'll change the size to your standard 8.5 by 11. All right, so now we are ready to start putting down components and designing our schematic. Let's kind of go through some of the key options of what we're going to do. So on the left, we can select if we want to be in inches or millimeters. Personally, I like millimeters. Just think it's easier to use, but use whatever you like, and you can switch between them interchangeably, which is often useful when you're looking at data sheets that some will be in metric, some won't be. Now, if we go to the right, we'll have a bunch of options. So a big ones you'll see is place symbol. You'll see place wire, and multiple others, and we'll use various of these throughout our design. So the first thing we'll want to do is we have our design here, and we want to essentially make that. So let's start just placing down the components without making the traces. Place down the components we need. So let's maybe start with some, resistors, LEDs of that sort. So we'll open here, we'll click, and it'll open up the symbol library for all the symbols. Now we have a ton of symbols through here that you can go through. I suggest playing around, looking through these. It has a lot, so there's some neat things in here. So first one might be resistors. Just from experience, I know that resistors are, the quick way to search is just R. So you have this resistor. I'm going to go to the slightly different version of the resistor, which is US. So the typical US version of the resistor. So we can place this down, and we need quite a few of these. So we know we at least need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 maybe. So what you can do is you can just hover over and press C, and it'll make a new one. So, we'll place a couple of these down. Oops. My bad. So yeah, just hover over and press C, and we'll get a few of those out there. We may need some more, but with that C command, it's super nice to use it. Another command that's super useful is hover over and press M. That allows you to move. You can also hover over and press R to rotate. Furthermore, you can press X and Y to flip horizontally or vertically, and we'll use those quite a bit. So learning those short keys, super helpful. All right, so we got some resistors down. Now let's get some LEDs. So we have 4 LEDs here. However, we were missing our green LED. So we'll put down 5 LEDs. So let's go back into our components, click, and let's search. So you can go through and search manually by reading through, or you can search it, but we'll go down here and we can see LED, and we can sort of click our way through and see if we find what we want. So some of those look good. I think they just have a simple one somewhere. Let's see. Maybe not. Let's just search LED. Ah, there we go. Your standard LED. So we'll have 5 of those. So again, use C. So we'll put five LEDs down. Notice I'm just putting down the parts without connecting together. So once we have all the parts there, we can arrange them in sort of the order we want to make the schematic look nice. And you may go through multiple versions of doing that. Next, we need these 4 push buttons here, so we can see if the library has it. Now, it is important to note that the library won't necessarily have every part you want. Maybe you find a very specific part. The great thing is a lot of parts on sites like DigiKey will have footprints and stuff that you can download specifically for KiCad. All right, so we are trying to find some buttons, so maybe we'll go switch. Yeah, that doesn't look like it showed exactly what we want. A lot of stuff showed up. So let me go back and let's go through and look. So I know there is a switch category. So let's go down. We'll go to switch. And let me just start going through these switches and see if. So I'm looking for more like a push button than a switch, but I believe it's under the switch category. So let's see. There we go. So this is a standard symbol for a push button. I believe there's a few more. So here's the one I want, SW push. So you can just search SW push now that you know it. So, and we have 4 of those. So we will copy and we'll just place them around. Next, we'll go with our big Arduino here and place that down. So you may be wondering, we're not actually putting the Arduino on our circuit, but we will want to fit the footprint of the Arduino as the hat sits on it. So we'll still want to show what pins of the Arduino we're going to connect it to, so we'll still bring in the Arduino footprint. So we can search and see if it has Arduino. Look at that, we pull it up, and as I said, with the Arduino R3, the only difference between the Uno R2 and R3 is, you can kind of see, is there's sort of 2 extra pins for the A4 and A5, and I think that's just for convenience purposes. So we'll bring that down. And notice I'm also not setting values to things like my resistors and stuff yet. We'll sort of do that as we go once we place them where we want them. All right, lastly, we need to pull up our potential, or our joystick. Now our joystick encompasses these 2 potentiometers and the resistor. So we will, we could try to look that up. However, I had a specific one in mind that I looked up. So let's show what that is. So what you might do is you might, simply go to Google, and the first thing is to search joystick, which is a great way to do it. Or you can go to a place like DigiKey, which is an electronics website that has just tons of electronic parts and really good ways to search. But naturally, the first thing I did was search joystick, and I know there's a company that makes just really good parts, and so I might go, SparkFun joystick, and let's see what pops up. So first, I actually see stuff pop up here, and the first one caught my eye. It looks exactly like I want, and so I click on it, and it actually brings me to DigiKey. You can also go through DigiKey's selection process, but that takes some time and some playing around with, so we'll just quickly grab what we want. But I encourage you to look around and see what other parts you may want to use. So this is by SparkFun Electronics, a great hobbyist company. And let's see, it's a joystick with a 10 kilo ohm 2-axis. That means we have 2 10 kilo ohm potentiometers, which is perfect for our scenario. And it also has that push down button, so it's much like a PlayStation 2 controller joystick. So we can see all these resources they give us. So we can click, they'll give us a data sheet. This is a pretty lean data sheet, not much here, but really everything that we need to know. So approximate dimensions and size. We also have Eagle libraries and what's the Snap EDA. So that's going to provide us our footprint for this component because it's not, natively in KiCad. So we will go down and we can select it so we can get the footprint for this. We can also take this part and add it to a bill of materials or save it in our cart, so that way we can get back to it later and order it once we actually build our board. You'll also want to make sure you go through and, for other components, meet the voltage, current requirements, and really study those data sheets. But this one's pretty simple. So let's go look at how we're going to get that component, because if we go through and search in our component library, we won't find it. So you click here and it brings you to Snap EDA. If you don't already have an account, you'll need to make an account first before you can download anything. It's free for most components, and it's just a library of tons of components. So the first thing we'd want to do is we see our component. It's exactly what we want. It has this cool footprint. We also have a 3D model, so we can see what it looks like in 3D. Pretty neat. But let's download the footprints and see where we'll save that. So we'll download it, and it'll bring up all the different formats. So we are using KiCad, I think 5 point something. So we'll want to choose KiCad V4 or later. So that'll give us the format. You can also click this and it'll show you how to download it and actually set it up, but I'm gonna go through that. All right, so we downloaded our component and it comes as a zip file. And what I did is within our joystick follower folder for KiCad, where all the KiCad files are, I created a components folder. And this is where I want to put just specific components that are just for this project. And then that way I'll be able to link them up within the footprint editor of the of KiCad. So if we go in here, we'll see I just put that zip file that was downloaded straight into this folder, and what I'll do is we'll extract it just right here, and we will see it extracted. We can go and look, and we see this .lib folder. Okay, so let me open the project back up. All right, so now we want to insert that component of the joystick. So we'll go back to, before we go to place symbol, we actually want to go to the create, delete, and edit symbols. That way we can add the joystick symbol in. So we'll let this open up, taking a second. So if we go, we will see it is not here. It was like COM 09302, something like that. And it's not in here. So we can add it. So what we'll go do is we'll go preferences, manage symbol libraries, and we could put it as a global library, saved on your computer. Comes with KiCad, or we can do just project specific. Since this really is for just this project, I don't know if I'm likely to use it again, and I want to be able to maybe share this project with somebody else. I'm going to put it within project specific libraries. So what we'll do is we'll come down here, we'll do add existing library to table, come up, and it opens up with, in our project folder. I'll open components to it and then click this lib open. So it should add that in, and we'll click OK, and now we can go check out the part on the left here. The COM 09032 was the part number of the joystick. All right, so there it is. Cool. So now we can go to, on the right side, and we can do our place symbol. So we'll do place, and we can go down. So there it is, COM 09032, and we can just place it down here. Cool. All right, so let's take a look at this symbol, because this is not your conventional symbol you would see in your traditional electronics class, right? So the symbol has a lot of different pins. So first we have this V and this H pins. So the V corresponds to the vertical axis controlled potentiometer. So there's 3 pins for that. There's your, the pin you pull high to 5 volts, the pin you pull low to ground, and then the pin that you read the voltage drop from, which is a voltage divider. Similarly, we have it for the horizontal axis potentiometer, and then after that we have these 2 select pins. That's just the push button. So when the push button's connected, it'll connect these pins. And then finally we have shield. Shield is just the pins to help hold the joystick down to the PCB, so they're just extra pins to solder to, but we'll end up connecting this to ground. All right, so now we have most of our components on this sheet. We may need to add some more, but we could start making some connections between them. So the first ones that I will connect is the joystick, and it's often smart to see sort of what pins your components are going to plug into to know what side to connect it to. So since I know I plan on plugging the potentiometer components of the joystick to the analog pins, I think this is a good spot because our analog pins A0 through A5 are right here on this side, and then we have a nice short path to connect. And we may maybe want to move it down, but this is fine. All right, so let's make some connections. So to make the connections, the wired connections between components, we'll go to the right and we'll click this green line, which is wire. And then we'll go simply, zoom in, click on the end there, and we're going to connect this one to A0. So the part without the plus or minus is the middle pin of the of like a potentiometer. So this is where you would read it's the voltage divider. Now we'll go to A1. All right, and then we said we wanted to connect the pluses to our positive voltage, which is going to be 5 volts for this. So we'll come off of the Arduino's 5 volts. So maybe I'll come out like this. we'll come over and we'll tap right into this 5 volts right here. Similarly, we'll pull the H and we will connect it to that same line. Now you'll notice when we make a connection where there's 3 points coming together, it creates a point. That means we have an intersection. At a point, say right here, we don't have an intersection. So these lines aren't connected. So just be careful of that. So this is exactly what we want right here. Now we want to connect the minuses to ground. So we will go pull this out. Now you'll see on the left, on the bottom of the Arduino, I have the ground, but I'm not going to reach all the way over and connect it. What I'll do is I'll just put this here. Escape will also connect this one to it. Right? And then what I can do is I want to go get one of those, I want to get a ground label. So we'll go into our place symbols and we'll just search GND, and there's lots of different versions. I'm just going to choose the first one. So we'll place that. Boom. Now what'll happen is KiCad will connect this ground to this ground automatically when we create a PCB. So these are sort of variables saying what parts should connect to each other, and will let us know how to route our traces. Cool, so we have the potentiometers hooked up. Now we need to hook up the button and the shield. Real quickly, let's do the shield. We're just going to ground that. It just adds extra metal, so it's okay for it to be grounded. So select our wire. And whoops, I overshot it. Cool, so connect that to ground. Now the push button. So the button, if we remember, oops, is also connected in the pull-up configuration. That means from 5 volts there is a resistor, and then we have our button down here, and sort of in between the resistor and the button is where we read the input on the Arduino. So when the button is not pressed, the Arduino will read 5 volts, and the reason that is there's going to be no current going through this resistor into the Arduino, because effectively the Arduino's input is infinite resistance. So if there's no current drop across R, that means we strictly just have 5 volts at this point. Now once the button is connected, then you will see that we would have D2 connected straight to ground, which is 0 volts, right? That's our reference voltage. And we'll have a little current going from 5 volts straight into ground. So when the button's connected, D2 will read low. So this is sort of active low configuration, meaning if you want to read the buttons turned on, then that means you read it when it's low. Okay, so let's do this connection. So this will be our positive side of the battery. So we'll take one of these resistors, we'll place it about right there, and we will want to connect from here. Oops. It's not wanting to turn the way I want it. There we go. So we'll go up, we'll connect to the resistor, and then we want to connect the resistor to this 5 volt line. Awesome. And then what we showed is we're going to take right in between the resistor and the positive end of the button, and we're going to bring that into D2 of our Arduino. So one of our digital pins right there that we can read as a digital input. Now, what we could do is we could make a trace all the way around like this, but that's pretty gross. It seems unnecessary, and if you have to do a lot of connections, it would become a wiry mess. So what we could do is we can use I'll place a label. So what I'll do is I'll take a label, and we'll call it B1 for button 1, and this label, we'll use one right here, and we'll connect it. All right. Now I'll take the same label, so I'll just press C and copy it. So it's the same name, so the name links the two like a variable in programming. And we will connect it. And so that sets the connection between this point right here, this node, in this node without actually physically having to trace all the way around. So these can help make your design a lot easier to read and just a lot nicer. All right, and then finally we need to connect this part to ground, which is the button. So this may not be the prettiest way to do it. Take some time, see if you want to make it look prettier, more spaced out, but it's good, just to get things connected, and then if you need to, go back and make it a little nicer, especially if you're going to hand it off to somebody to work on. All right, so we got the potentiometer all hooked up. It's looking good. We'll wait to do some of the resistance values, and we'll talk about why we choose those values later. All right, next, let's hook up the diodes, or the LEDs, and their resistors. And so I'm going to take these and we're going to move them down here. And they're decently lined up. So we will take them, and I don't like how they are positioned, right? We got these arrows pointing down. I feel like it would look a little nicer if they were pointed up. So what I'll do is to flip them. We want to flip them across the horizontal x-axis. So we'll just hover over and press X, and look at that. There we go. So now we've flipped it. We'll also need these resistors. So I'll make copy one of them. You can move them. And we don't want it to sit sideways like that. We want it to be in line with the LED, since it will be the current limiting resistor of the LED. So we'll rotate it. Well, let's rotate it. Let's see. Let's rotate these as well. So we can go move. There we go. Set it up nicely. And we'll make it, in line with this. And what I could do is I could copy and generally line it up. You can get nitpicky with it later. So we'll, copy, copy. And then maybe we want to move this one a little back. All right, so they're pretty well lined up. And so now let's make the connections. So we'll go, we'll start at D13 on this bottom one. So let's select our wire and we'll click here. We'll go nice and close, make that connection. Similarly, we'll go here, come nice and close in, keep going through. So we got all right. Cool. So we got it hooked up to Arduino. Now let's make the connections in between the resistors and the diodes. All right. And again, we'll wait a little bit to put those resistor values on. And then let's connect all the cathodes of the LEDs to ground. So we'll kind of bring this down here. And then I'll come and take one of these ground symbols and I will copy it, bring it over. Awesome. Now it's connected, and let's take wire, boom. Connect all those to ground. You can make things look pretty uniform and pretty. Whoops. Accidentally grabbed it. All right. So now the LEDs are all hooked up. So those are 5 LEDs, the 4 for indicating the joystick direction, and 1 LED for indicating the when the push button on the joystick is pressed down. Now, these all say LEDs, but I wanted the red LEDs to be those direction indicators and a green LED to be when the button's pushed. So what I might do is I might double click on this and we can see reference and value. We're going to hold off on reference right now because KiCad will automatically assign the references. So we'll have D1, D2, D3, D4 for our diodes, R1, R2, and so on for all our other components. But we'll change the value. So we'll say red LED. So we can go through and do that for each of these. Right. And then the last one we'll say it's a green LED. Nope, I said we're going to say it's a green LED. Cool. All right, so those are our LEDs. Now, lastly, let's get all these buttons hooked up. All right, sorry. Switches, buttons. They call them switches, but they're sort of push down. I think it was a button. Okay, so let's find a nice way to sort of put these together. So what I'll do is I'll move them vertically, like so. And those are a little too far over. So let's kind of move it like this. All right. So we will, let's see how we're going to hook these up. So if we go back to our picture here, we have, they're also hooked up in the pull-up resistor configuration. So we're going to have our plus 5 volts through resistors, then the connections to the Arduino inputs, and then our buttons going to ground. So let's get that going. So what I will do is let's connect the grounds of the switches. So we'll do that on the left side, and we'll just come right over to that sort of ground bus we have here. Awesome. And then we will also, now we'll, what I'm going to do is I'm not going to put the resistors right away. I'm going to put that sort of positive, or that point we're going to read from in between the button and the resistor. I'm going to connect those to the Arduino. So let's, we may want to move, the label on D2 to make this nicer, but we could do something like this. So we'll come down. Yeah, and you could probably find ways to make this look a little nicer, fit a little better, less of this amount of angles I'm doing here. But, let's get it together. Yeah. So there might be a better way to space those out, which would look a lot nicer. Now, we need to pull up on those pins. So what I'm going to do is I will just move this. We'll start with the first one, and I will sort of, let's get it on that bottom switch. So let's zoom in, place a wire, sort of connect it there, and pull more of those resistors over. So we need 4 of them. All right, so let's make these connections. So we'll do nice connections like this. We already got that bottom one, so there we go. So now we're pulling up each of the switches up. All right, so now we want to connect this to the 5 volts over here. However, it would be quite a long trace to come all the way up and around. So another one we can do, so we had that place global label. We could also just place a net label. For now, you could think of them sort of the same, but we'll just do one of these to show. So we'll call this 5 volts. and I will place it. So that'll 5 volts, and similarly, we'll come here, we'll connect each of these because all of these are going to connect to 5 volts. Maybe. And then we will select another one of these. Also call it 5 volts. So that way they're linked together, and make that connection. There we go. So now these 5 volts will be linked to each other. Okay, so we have our schematic together. We have 2 extra resistors we don't need here. So we'll just click on them and press delete. There we go. So we have our schematic. So now we're, hopefully pretty confident in our schematic and our design. And so, we may want to think, all right, let's go to the PCB design. Well, we're still missing some parts. So first off, we'll notice each of these components has a designator with a question mark. So what we need to do, we need to annotate them so they each have their own specific designator. So resistor 1, resistor 2, and so on. That'll help any users know which resistor goes where with what value. So what we'll do is we'll come up here and we'll go annotate schematic symbols. We'll click it. The scope, use entire schematic. Yep. We want to keep existing annotations. We don't have any yet because you'll notice everything has a question mark. And then, yeah, so you can look through these, but we'll keep it how it is and we'll annotate. So this assigned designators. So if we close it, so now we'll look, and each of the switches will have a, S1, S2, S3, S4. Each of the diodes will have one. And if you don't like the order they're given in, you can manually set them, but we'll just keep it as it is. All right, so now we'll want to set some values. So on this resistor, we need to know how we're going to select this resistor. So I'm not going to go fully through on how to select resistors for these LEDs, but generally what you do is you go into the LED's data sheet, you look at what its voltage drop is and what its rated current is. So in examples, the voltage drop might be 2.1 volts nominally, and with a rated current of 20 milliamps. So that means you expect to see 2.1 volts across the LED, and you want to be throwing 20 milliamps through this resistor and through the LED. So in that case, if we're driving this pin with 5 volts and we know we have 2.1 volts here, we can take the difference, divide it by that 20 milliamps, and then we'll get our resistance. In this case, when I estimated it out, it was about 160 ohms for these resistors here. So we'll go through and we'll change the value. So we'll double click the thing, we'll go value 160. Furthermore, you can just kind of click on the actual value itself. Be a little bit faster. There we go. So we got our resistors there, and they're 160 ohm. Furthermore, these pull-up resistors can be pretty high because they're just making sure we don't, short the 5 volts to ground when the button is pushed, since the current will want to, when the button's pushed, the current will flow, through the resistor and to ground when the button's pushed, since the impedance of a Arduino that's reading the voltage is close to infinite. So we just want to throw a little bit of current through there. The only thing is we need to make sure that these resistors are not comparably high resistance as the supposedly infinite or really high input impedance of the Arduino. But don't worry too much about that now. I'll just give generally good value used for these will just be 10K. So So we'll go through. Let's go. All right, there we go. And switches don't really have a value. We could, give the name of the switch, and maybe we'll do that, but for now we'll just read it. We'll just let it be SW push. All right, and everything looks good over here, so that looks great. So, we set our values for our resistors. Whoops, we forgot R10. So R10 is also a pull-up resistor, so we'll also set it as 10K. All right, so now we can go ahead and it's annotated. So what we'll do next is we'll perform the electrical rules check. And this is going to let us know if things aren't connected properly and if we're missing anything important that'll be needed for the PCB. So we'll open this up and we'll simply just press run. And whoa, we get a lot of errors. Now you'll see the errors is pin not connected. Well, if I go through and look, we see all these pins are not connected, and it actually points to it. So what we can do to get rid of that error, we can come to the right and we can press the no connection flag. We can go through each of these and put one on it, and that'll get rid of that DRC error. All right, so I think, whoops, so it says this one's not connected. That might not be a disconnection, that might be a different error that we'll show. All right, so let's go back to our DRC. So we think we fixed all the disconnects, and there we go. So now this one is different. So we have pin connected to other pins, but not driven by any pin. So this happens for nets that are what we call power nets, and an example of that is ground. So what we'll want to do, just as sort of rule of thumb, and this is just for the design rule checker, is we'll come into our components library and we'll go to power flag. So we'll search PWR flag and we'll select power flag. And we'll just take this down here and we'll select a ground. And this is just a flag. This is specifically for the rule checker. This won't be anything on your PCB, and it just says, hey, this is a like a power type trace. So ground, maybe your 5 volts you also want to put there. So we'll notice if we put that and we run our DRC, awesome, 0 errors. So that's great. So circuit's looking good. We're almost ready to move on to the PCB stage. However, before the PCB stage, what we need to do is we need to assign these symbols with the actual physical components. And this part can be quite tedious, but this is really the next step before we go to PCB. So since we don't have any errors, we'll go to assign PCB footprints to schematic symbols. So we'll wait for this to load. It can take a couple minutes sometimes, or it can be pretty fast. So we'll just wait that through. And we're likely to get an error possibly when this pops up because we added a new component. Sometimes there'll be errors because maybe it's a legacy component, so it's not the newest version, but we'll handle that. Almost done. It's loading up all those 3D footprints. So there's quite a lot of them. All right. Yeah, so here we go. So we got an error that are legacy entries, and it wants, it says, would you like to convert or attempt to convert them to the new libID format? So we'll say yes and see if it'll help us. So on the left here, we see footprint libraries. So this is similar to the symbol libraries where you went in and you found them, except these have all the footprints. So, as an example, we could go into this button switch keyboard library, and then we can go to the far right here and we can see all the different versions of these. Something cool too is for each of these is you can come up here to the left and view the footprint. So we'll have that, and we can go through and look at all of them. So sometimes it helps to sort of move this maybe over and you can go through sort of like this and sort of look for what you're looking for. So if you know generally what your part looks like, this can be a way to go through and look at it so we can see tons of different stuff. All right, so let me shrink this a little bit. So you'll see some of our components may already be filled in. So as an example, these are all of the references to all the components we had, and we want to make sure we assign them a footprint before going to our PCB stage. So if we look at A1, it says module Uno R3. So it already pre-assigned one, but we can change it if we like. So let's go look at module Arduino Uno R3. So we'll go to module, so go on the left side here, look for M, module, and Uno R3. So this is what it looks like. Now this is great. So it has the pins, with the correct sizes, dimensions laid out for us. That'll be perfect for the Arduino Hat. Because what we're going to do is we're just going to simply solder header pins onto it. So that way we can just push it on top of the Arduino. But it gives us sort of what the dimensions should look like. So that's exactly what we want. They also have a version with mounting holes, which might be nice because then the drill can cut these out. So maybe you want to be able to put your screwdriver through it or something. But we're not going to use that for now. So we'll just keep this. That was one already selected. Now we can also go to our component down here, which is our joystick, and that one was already pre-assigned too, and that's exactly what we want. This is the one we downloaded from Snap EDA. So now we got to go through the rest of our components. So we're going to go through the LEDs, and we're going to choose our standard through-hole LED. So what we'll do is we'll go on the left here, and we'll look for LED or something like it. So LED through-hole, we're going to use through-hole. There's also surface mount. We'll talk more about that some other time. And so we can go through all these different types. You'll get pretty good at reading these. And a lot of times you also have to associate it with the data sheet to make sure it's your correct size. However, I'm going to use a pretty standard LED, which is a 5mm LED. That kind of sits vertically. So we will put this in, and we'll just click it multiple times to put it for all the LEDs, because all the LEDs are going to be the same size. Cool. So we have all our LEDs done. Now we need to go to our resistors. We're going to use just typical regular through-hole resistors as well, and these usually have 40 mils between the holes. And if you have a resistor, you can measure and see which sizes you like. But we'll go down here, and we'll click resistor through hole, and we'll look at all the resistors. So I am specifically looking for 2.5 and 10.16. So this one right here is perfect for an axial resistor. And we have all these resistors, so we'll go through. All the resistors are going to be the same mechanical size. All right, so we have all of those components. Finally, we need to use our push buttons. Now, we didn't discuss exactly what the push buttons would like, and there's tons of different types of push buttons that we might choose. Often we use a 4-prong one. So what we can do is we can look up one that we might like, and I found one that I like, so I will show it here. Okay, so if we go in and look, I have already found it on DigiKey, and one cool thing is I saved it in a BOM. So I started creating BOM, which is Bill of Materials, BOM, and um, I found some cool, really big multicolored buttons that'll be perfect for this, give a nice look as well. So 4 is exactly what we need, and they have these, but we need to know what the dimension of these are. So what you often do is just pull up the data sheet, and we can look at this dimension. So this is 12.8 mils plus or minus 0.03 mils. For the long ways between the pins, and the short ways between the pins is 5 mils with 0.2 tolerance there. So we want to find hole sizes that are similar to this. So we will go through and we will see if we can find one sort of matching these components. So let's come back in here and we'll see if we can go find some buttons. So I know we have the buttons through hole. Again, these are through hole. We're going to push them through and solder to the other side. So we'll go button switch and we'll go down and look. Now I'm kind of going to cheat because I already know what it is, but we'll see a sort of a switch and it'll be push 12 millimeters. So, that sort of gives what the width is. Now to check, what we can do is we can come into our 3D view, we can click, and I'll hover over this center pin. And what I'll do is I'll click on it and I'll press space. Now if you look at the bottom where it's a dx and dy, you'll see those are zeroed out. Now as I move this, so that kind of set our reference point. And I can move it across to the center of the other pin, and we have that's 0.49. Oh, that's mils. Sorry, I think the other thing was in millimeters. So we want it in millimeters. So again, I'll set it as 0. We'll come over, and we have 12.44 millimeters, which is, this thing's not perfect, but it's the size of the pins we're going to use. And remember, we'll be able to slightly bend those pins when we actually go to solder and build it. Similarly, as we can go back here, press 0, we can go up, and we can see it's about 5 millimeters between on the short way. So this is exactly what we want. So we'll fill that in. All right. So we have selected all the components. You can go through and just look, make sure they're what you want. So all the resistors, LEDs, and Arduino. So now we can just press apply and save schematic. Okay. Always make sure you're saving as you go. Control S, make it second nature. And you assign everything. Now the last step before going to the PCB part, which will be covered in a different video, is we will generate this net list. And so what this does is this takes everything that we just put together, how everything connects, the PCB footprints, and creates a file showing how to link those. When we open up our PCB designer, we'll import that net list, and it sort of keeps the connection between the schematic and the PCB. So we'll just simply generate it. It's probably the easiest part. Just as is, generate net list, and it'll save right here in your folder. So you just press save, and you're done. You're ready to move on to designing the PCB. All right, so that is the schematic design portion. In the next video, we'll cover how to do the PCB design, where you'll actually get to see it physically in 3D. Hope you guys enjoyed. Hope you learned something. Thanks.